Okay, in example 10, it tells us to find the exact value of tangent of 5 pi over 12, and for alpha is 2 pi over 3, and beta is pi over 4. Alright, so we got some work to do on this one over here on the side before we get going too much, okay? So first thing is, if we want to know, we know then that tangent of 5 pi over 12 is equal to tangent of alpha, so 2 pi over 3, somehow combined with pi over 4. But am I going to add them or do I subtract them? Well, let's go over here to the side and let's think about it. So we got 2 pi over 3 and we got a pi over 4. Let's see, if I get a common denominator there, remember we multiply by the other one's denominator. So this would give us, what, 8 pi over 12? And this would give us 3 pi over 12. When I add or subtract those, I get a 5 pi. Well, if I take 8 pi and 3 pi and I add them, that's 11 pi over 12. That's not what I want. But what's 8 pi minus 3 pi? That's the 5 pi that we want. So we're going to subtract them. So that means that we're going to use our difference formula. Alright, so let's write out our formula. So it says tangent of alpha, the 2 pi over 3, minus tangent of beta, the pi over 4, over 1 plus tangent of our alpha, 2 pi over 3, times tangent of our beta, which is pi over 4. Alright, well, we can see there we're going to need we need to know about 2 pi over 3 and pi over 4. So 2 pi over 3 has an ordered pair of negative 1/2, square root of 3 over 2. It's on our unit circle. It's in quadrant 2. And pi over 4 has an ordered pair of the square root of 2 over 2, square root of 2 over 2. But now notice we're doing tangent on both of them. So that's tangent's not just x or just y. Do you remember what it is? Yeah, tangent is x over y. So I'm going to go ahead and find the tangent of both of these. Now, a while back I told you, back when we were still in class together, I had told you if you wanted to go through and find all the tangents and put them on your plate, it would be helpful. Because that way you wouldn't have to do it each time you were looking for it. Well, some of y'all might have done it. Some of y'all probably didn't do it. So I'm going to go ahead and work it out here so you can see how to get it. But I'm advising you to go through and do the tangents for all your angles. Alright, so tangent of 2 pi over 3. Remember, tangent is y over x. And so for 2 pi over 3, our y value is the square root of 3 over 2 over the x value, which is negative 1/2. Well, you can do keep it, change it, flip it, or remember, I just multiply by the little denominator. And so, because those will cancel, and so that means that we've got on top, we have the square root of 3. On bottom, we're left with negative 1. And so the tangent at 2 pi over 3 is the negative square root of 3. Then I'm going to go find tangent of pi over 4. Again, y over x. So y is the square root of 2 over 2. X is the square root of 2 over 2. And this one's nice because we know anything divided by itself is 1. And so now I found some pieces that's going to help me when I go ahead and plug this in. So let's do that. So this is tangent of 2 pi over 3, which we know is a negative square root of 3. And watch me on my signs here, guys. Every time I seem to work this problem, I have to go back and correct myself on signs. So just be careful. Just watch them. So then we got our formula says minus tangent of pi over 4 is a 1 over 1 plus tangent of 2 pi over 3, so negative square root of 3, times tangent of pi over 4, which is 1. So in the numerator, I got the negative square root of 3 minus 1 over, and the denominator, I got 1 plus a negative is a minus square root of 3. But we can't have a radical on bottom, remember? So we're going to need to rationalize our denominator. And so that means we're going to multiply that times the conjugate of the denominator. Well, the denominator is 1 minus the square root of 3, so its conjugate is 1 plus the square root of 3. And so what you do to the bottom, you have to do to the top. And so it means we're going to get to do FOIL on both of them. Alright, so let's do this. Be careful of signs here. This is where I keep seeming to get myself flip-flopped a little bit. So we get the negative square root of 3 times 1, which is a negative square root of 3. Negative square root of 3 times a positive square root of 3. Well, negative times a positive is a negative. Square root of 3 times the square root of 3 is just 3. Negative 1 times 1 is negative 1. And negative 1 times the square root of 3 is a negative square root of 3. Over, we're going to do the same thing in the denominator. 1 times 1 is 1. 1 times the square root of 3 is a positive square root of 3. Negative square root of 3 times 1 is a negative square root of 3. And the negative square root of 3 times a positive square root of 3, negative times a positive is negative, square root of 3 times square root of 3 is 3. I think I got my signs right that time. Alright, so let's simplify. So on top, I'm going to go ahead and put my whole numbers first. Negative 3 minus 1 is negative 4. Then my radicals, the negative square root of 3 minus the square root of 3. Remember, you add or subtract the coefficients and you keep the radical the same, okay? So this is like negative 1 minus 1. So I have minus 2 square roots of 3. Over, in the denominator, these are like terms, so they're going to cancel. And so we got 1 minus 3, which is negative 2. Now notice they're all negative, and so I'm going to take a negative out of them. And the 4, the 2, and the 2 are also all divisible by 2. So I'm going to take each of these numbers, not under the radical, and divide them by negative 2. So when I do that, I get 2 plus the square root of 3 over 1. And we don't need an over 1 there, so we just get 2 plus the square root of 3. And there's our solution.